Now, our unit rate is a specific formula that helps us compare a quantity to exactly one singular unit of another. So say, all right, so let's look at an example here. So if I am thinking about the one we've had in class before, all right, it's going to say that you went to a store and they had a deal saying all right, make this a striped jersey. Number 17. All right, so if I say that they have a deal going on, 25 for 5. All right, so I know that that means that for 5 t-shirts, it'll cost me $25. So I want to know if that's actually a deal or not. So I need to find the one singular unit. And I set that up exactly like our previous unit with one-step linear equations, where I put x over 1. And the comparison I'm making when we talked about our ratios in this is we have a thing to a thing, okay? This to that. So I need to focus on how I'm putting that into the structure. So here I put cost over quantity. All right, so I do the same thing over here. Cost over quantity. All right, now looking at this, hopefully like you can figure out by just looking at the numbers, but if not, we're gonna follow the same process as our one-step linear equations. Now, here is the trick. You are going to do what we call cross multiplying, or the butterfly method. I've heard that one used before. So we sit there and take and multiply diagonally. All right, you can either draw like the X through this like that, or you can circle them. Both of those are functional ways to look at this. So on equal sign, one of our sides, we're gonna have, let's do this one first. 25 times 1, which we know is 25. And I'll put that here, so it's clear which direction we're going. Now 5 times x, all right? That's gonna be in our blue box. Just keeping this color-coded for everybody. All right, now we're just solving for x to figure out what is our cost of one singular unit. So I know to do that, I follow my steps of dividing out my coefficient, since this is multiplication. Do the same thing over here. All right, 25 divided by 5, x equals 5. So if I look at this and say that they're selling 5 jerseys for $25, is that a deal? Well, depends on how much the shirts are regularly, but as I'm looking at it, they're just $5 each. All right, so one single jersey is $5. So you're spending per. All right, now I also want to look a little bit about when we are writing into a chart. Okay, so we'll see this model throughout this unit. All right, Now, I want to say, let's have a, hopefully everybody has seen one of these. All right, so speed limit sign says the speed limit on a certain road is 50 miles an hour. All right, so naturally that tells me that in 1 hour, I will drive 50 miles. 50 miles in 1 hour. So I put distance over time. All right, so let's see here and say to ourselves, okay, all right, I want to know how far I would travel in 3 hours and say 3.25 hours. All right, so kind of blends a little bit of our, already looking at our proportions, our ratios, and also looking at converting decimals to fractions, breaking down things as time, like in time. So let's figure this out here. So if 3 hours and 3.25 hours. So if our ratio is 50 to 1, and I'm trying to figure out 3 hours. All right, so I need to figure out how much is this smallest increment here. So I put 50 over 1. All right, so, well, let's look at this. What is half of 1 hour? 30 minutes. We can represent that half as 0.5. All right, and half of 30 minutes is 15 minutes. And half, so we'll represent that as 0.25. There's that right there. All right, and we'll say 2 hours here. All right, so 50 to 1. All right, so it'd be 50 so go this right here and say times 50. All right, now this right here is specifically called our multiplicative relationship, which means it has to be a relationship that's based on multiplication only. So if I go here and I say this is times 50, all right, I'll say this will do the same thing, times 50, times 50, times 50. Now, following my process, let's start going back this way to figure out this, this part right here. So 50 times 0.5, all right, would be like 50 divided by 2, but half of 50, you could say 0.5, half of 50 is 25. Half of 25 here, so 50 times 0.25, say a quarter of 50, is 12.5. All right, now let's go to times 2. So 50 times 2 is 50 plus 50, we know it's 100. All right, and we see that if we go to our next box over, look at that perfect line there. All right, we see that we have 3. All right, so times 50. Now, if we do 3 times 50, if you're not good at your multiplication, you can write it out. There's also a trick with sitting there and saying, like, since this is 50, okay, it has like a 10 involved there. What we can do is we can take the 10 away and bring it back later. Let's say 5 times 1 equals 5. 5 times 2 equals 5. 5 times 3 equals 5. And now we just bring back the 0. 0, 0, 0. Go here, 50, 100. So 5, 10, 15, 50, 100, 150. All right. All right, so if I'm looking at my problem of 3.25 hours, I have 3 hours and 0.25 hours. So I know that my distance I'll travel is 150 miles plus 12.5 miles. So I say that in 0.25 hours equals 162.5 hours. All right, miles, sorry.